Hey guys, welcome back to my channel Tech Fit. This is Garv, and usually in my video content you would see a lot of different projects that we work on within Python. So today what I want to cover is going really in basics of Python. So this video would be really good for people who don't really know much about Python, who are trying to learn Python, or maybe even if you know some basics, that would be good as well to tackle on. So again, I hope you enjoyed this video. Again, this video would be slightly long and I won't be doing any editing in the video because I just want to cover all the different fundamentals of the programming and also going through the basic data types and moving towards what exactly you can do with Python. So we'll try to cover as much basics as we can within this video, and I hope you enjoyed this video. Give it a thumbs up if you like the content, because it definitely does help me, or it motivates me to actually put more content out there. So without wasting any more time, let's begin coding. So first thing first, how do you install Python? Again, I'll leave all the links in the description below. Again, you can just install your Anaconda Navigator, which actually installs automatically your Python. It also installs your Jupyter Notebook, which we'll be using in this video. And also there's another IDE you can actually use for Python as well, which is Spider. Again, these are the three main things that I use as well within Python. Again, I do use Jupyter Notebooks a lot of times. And again, I use IDE, which is Spider. And then again, Python will be installed within Anaconda Navigator as well. And as you can see on the screen right now, once you install Anaconda Navigator, it actually has all the options that you can actually launch your notebooks, or you can actually launch your Spider IDE as well. Again, you can also link your RStudio in it if you're using R, and if you're an R user, that'll be good as well to bring it into your Anaconda Navigator. It actually helps you to manage all your packages in one place. So I'll definitely recommend to use Anaconda Navigator for this. So let's start with basics. As you can see on the screen right now, what we will cover now is the different data types that we have in Python. Again, you don't really have to learn all of these data types straight away. Again, we'll be going into more details when we are looking at examples for each data types, and we'll look at more definitions in more detailed way rather than just actually looking at in this list format. Again, starting with on the top, we have integers. Again, integers are noted as int in Python data types, and they are basically your whole numbers, such as example could be 3, 300, and 200. And then you have next, which is your floating points. Floating points are noted as float type in Python, and basically these are numbers with a decimal point, again, which could be 2.3, 4.6, and as you can see, 100 is a whole number, but again, because there is a decimal point 0 attached to the 100, that's why it becomes as a floating point number. Then next we have strings. Now strings are just your order sequence of characters, which again could be anything, could be hello, Sammy, or you could have 2000, which is again an integer value. But because it is between that coded values, that's why it converts them into as a string. And you could also have different language characters as well, such as the Japanese characters. Then we have next, which is list. List is basically your order sequence of objects. Now within list, you could have integer values as well, or you could have string values as well. Same way, you could have your decimal values as well. And as you can see, list is basically coded into your square brackets. Same way, you have then dictionaries. Dictionaries are type which is noted as dict, which is DICT, and then basically it is your unordered key value pairs. Dictionaries are always within curly braces, and you can have an as example my key, which has value, which is again colon, and then you have your value. Same way, your name is your key, and then Frankie is the value for that key. Next you have is your tuples. Sometimes tuples are also called as tuples, and within tuples they are basically mentioned as a type, which is tup, which is TUP. It is just an ordered immutable sequence of objects. They are basically noted within round brackets, which is different to list, which is in square brackets. Then you have your sets within Python, which is one type of data type, which is an ordered collection of unique objects. It could be anything as from A, B, and it also is noted into curly braces. Now last is your boolean, which is again a Python type, which is noted as bool, which is BOOL, which is your logical value indicating true or false. So these are your different data types that you have in Python. Again, within this video, I don't want to just cover these theory, and I don't want to just bring you out to end and make this really boring. But what I want to cover is show you different types of examples within when we start using them. So what I'm going to actually do is I'm going to open my Jupyter Notebook, and we'll actually start coding, and we'll actually start using lists, using dictionaries, and then we'll cover a bit of definitions of the background, but we'll be actually using them as a real life example. And within this basics, again, we'll be stepping up level every time we look at something basic. Then we look at, okay, how do we create modules, how do we create packages? Without wasting any more time, let's open Jupyter Notebook and actually start coding this, so actually we have a better understanding of Python. So we do have a basic understanding of what different data types that we have in Python. Now let's start using them and see what examples are there we can actually cover within these to actually understand them more in detail. So what I'll cover now first is, as you can see, my Jupyter Notebook is now open. So I'm actually going to create a new variable, and I'm going to basically assign different types of variables types into that. So it could be like an integer, it could be float. I'm just going to say cost is my variable, and what I'm going to say is cost is equal to 100. So as you can see, I have just created a new variable, which is cost, and then where the value of that cost is an integer value, and I'm basically saying is equal to 100. So I'm just going to create another variable as well. Say I have key as safe, and where I'm actually going to give it a value as 2.5, and as you can see, this is again my floating point values. So I'm just going to say name is equal to, I'm just going to say my name, which is Garv. So as you can see, we can do that. And also we are going to look at one of the examples of how do you actually create a variable that could have a Boolean type. So what I'm going to do is create a variable called isActive, and I'm just going to say equal to is true. So these are your different types of data that you have within Python. So we are just looking at how do you actually create a variable for those types of data. So what I'm going to do is, as I said just there now, which is cost is equal to 100, what I'm going to now do is I'm going to say print, and I'm just going to say print my cost. So I'm just going to print the variable that I just created, and I'm just going to say control enter, and then it just basically says the value, which is 100. So as you can see, I just printed my variable, which was cost, and same way I can print any other variable that I just created now. If I say print name and just press control enter or alt enter, if you press alt enter, that just basically creates an extra cell on the bottom. So usually maybe I'll actually do alt enter, because then I just have an extra cell, so I can just keep printing my commands in this. So as you can see, whenever I just say print, I can easily print my variables, and this is how you kind of like look at your different types of variables that you have, and you can print them on your console window. You can actually print multiple variables at the same time as well. So what I'm going to do is I'm going to say print customer, actually I'm going to put that in brackets and say customer name is, and then secondly what I'm going to do is provide a comma, and then I'm just going to pass on the name. Similarly, what I'm going to also say is active or not, and then I'm just going to pass on the value, which is active, which is my variable. Once I do that, as you can see, customer name is Garv and is active or not is true. You can actually also see what type of data it is. You can basically just say print, and you can actually say what is type, and then within that type you can actually pass on your variable. So in this case, I'm actually going to say what is safe, and I'm going to press this, and as you can see, the class is float. So basically my variable that is there is actually a float type of variable. So now, a lot of the times when you're working with Python, if you have a certain type of data and you actually want to create into some different type of data, say for an example, if you have something in integer value, you actually don't really want to use it as integer value, you actually want to convert that into a string value. How do you convert your variable types? I'll actually leave more comments on the notebook, because I'll be putting this notebook in GitHub account, so you can actually pull it. You can actually code along with me while I'm creating different data types or different functions. So as you can see, I've created another variable, which is cost, and I'm actually going to give the cost value as 200, and which is again an integer value. But what I'm going to do now is I'm actually going to convert my cost. So I'm just going to say another variable, which is again could be as string cost. And within that string cost, what I'm actually going to do is str, and then I'm going to pass on the variable, which is cost variable. And once I do that, so basically that variable cost is now converted into a string variable, which is string cost. And to see the type, again, what we'll do is we'll do print, and basically we'll say type. And within that type, I'm actually going to pass on that variable which we just created, which is a string cost. Once I do that, you can see the class is string type. So this is how you convert different types of variables. So if you have integer, you can actually convert that into a string. Similar way, if you have a string variable, you can convert that back into an integer value. So next we are going to look at really basic examples again, which is again, what are the different types of operations you have within Python. So we are going to mention these as operations. So within these operations, what you have is you can actually do 10 into 5. And if you press enter, you can see in the console, you have 50 as value coming up. Similar way, you can actually do something like 5 divided by 5, which if you press enter would be 1. Similar way, you can do different types of operations like addition, subtraction. So one more operation I want you to look at is like module, which is again 5 module by 2 is equal to 1, which is the remainder value when you do a division. So now these are the different types of operations. So what we have covered so far is we know different data types from the start. We do know different types of operations that you can do within Python, and we do know how to convert different types of variables, and also looking at how to actually assign a value into a variable and how to print that variable. So now what we have covered all these basics. So let's start looking at more advanced data structures like lists and dictionaries. So let's cover lists first. So lists are one of the most important data structures that you will use in Python. List is basically mutable. Again, what that means is that if you have a certain values in the list, you can always go back and you can change the values in the list. And the index for the list always starts from 0. Again, where you are basically creating a new list, you would always see that it actually starts from 0, 1, 2, 3, rather than starting from 1, 2, and 3. Exact same way that you have in C, Java, or JavaScript if you're coming from different programming background. If you're coming from the scratch, you don't really know any other programming language. Again, it's just to have that in mind that index in Python always starts from 0 rather than starting from 1. And then the last thing is lists can contain any data types within the same list. So what I'm going to do now is create a blank list. What I'm going to do is x is equal to square brackets, which is again is your blank list. And once I click enter on that, so we have created a new list, which is a blank list, which is x. So if you want to really see it as well, you can actually say print x. And as you can see, it just shows back that blank list. There's no values within that list yet. So within this, what I'm actually going to do now next is I'm actually going to start creating more values within my list. So what I'm going to say now is x is equal to, and within that list, I'm actually going to put some values. So say for an example, first I'm going to actually put on a name. So say for an example, I put a name Louis. Then I'm going to move on to the next one. I'm going to put another value, which could be 1, 2, 3, which is again integer. So as you can see, I'm putting string values, I'm putting integer values. I'm actually going to put one floating point value as well as 100.0. And then I'm also going to put, now you can actually create lists within lists as well. So I have my main list, but within my list, I'm actually going to create another list as well, which is 1, 2, and 3, which has different integer values as well. So you can actually put any different types of data within your list. You can actually put lists within lists as well. So once I do that, what I'm actually going to do is after this, I'm actually going to print my list again. So I'm going to just say print x. So as you can see, first obviously it prints out the blank list because I have two print commands within my statement. Then I do have x where I'm creating my list and putting the values within that list, and then I'm printing that. As you can see, it has different string values, different integer values, floating values, and then it also has another list within my list. So as we mentioned, the index in Python always starts from 0. So say for an example, if I want to pick up a value from my list, so if I say something like x1, so as you can see within this, when I say x1, and because I want to see the value which is there within my list, and as you can see, x is my list, so I have to say x square brackets 1 because I'm looking at the value which is there in the first index. So you would usually think that value would be Louis, but because in Python the index starts from 0, so it will actually print my integer value, which is 1, 2, and 3. So as you can see, when I actually extracted that value, it is actually 1, 2, and 3. That's which kind of shows that index in Python starts from 0. Similar way, if I would have said something like x0 and I would have printed that would give me the value which is Louis. So I hope it kind of clears out that in Python the index always starts from 0. Similarly, within this, if I want to kind of like look at, say for an example, if my list is huge and I don't really know exactly how much values are there within that index, but I do want to see the last value within my list, I can also do something like x and I can say -1 and I can print that. That would actually print out the last value which is there in my list, again because it is a list within a list, so it just shows my last value which is the list, which is 1, 2, and 3. So similar way within Python, what I can also do is I can show different values altogether. So say for an example, if I don't want to show the whole list, I want to show values that are there from index 0 to index 2, I can actually just print them out in a way saying x0 colon 2, and if I print that, that should just give me the two values, as you can see, because it's value from 0, 1, and it doesn't really print the second value because it's not really inclusive of the second value. So next within my list, what I want to actually also look at is how do you append values in a list, how do you extend it, or how do you concatenate it. So in these three examples, what we were looking at is first is append. So what I want to kind of do first to start with is I'm actually going to create a new list. So within this list, I'm just going to say x is equal to 1. So that's my list which has a value, integer value, which is 1. But within this list, what I actually want to do next is I want to append a value. So what I'm going to actually say is x.append, and I'm going to append it by 2. So once I do that, and within that append, I'm going to actually show you one more example, which is extend. So what I want to do now next is x.extend. So what I want to do is x.extend, and then within that I'm actually going to say 3 and 4. So as you can see now, the value which should be printed for list x. So if I say print, x should be 1, 2, 3, and 4. And as you can see on the bottom, the list is now printed in the bottom where I just created the first list, which was x is equal to 1. Then I did was x.append as I appended the value 2 on it. Then I actually basically created x.extend where I extended the values within my list from 3 and 4, which again kind of like showed in the last one. I said print x, it printed my list, which is 1, 2, and 3, and 4. So this is actually how you append the values within your list or extend the values within your list. And now we are going to look at one of the examples for how you concatenate the list with second list. So what I'm going to do that is I'm going to say y, which is in my second list. Within that actually I'm going to just do all in one line. So I'm going to say y is equal to x, which is my first list. Then I'm going to just say plus, and I'm going to mention my second list, which is 6, 7, and 8. So as you can see, what I'm doing is I'm adding my one list into the other list, and then I'm going to say print y. Once I do that, as you can see, my list is 1, 2, 3, 4, 6, 7, and 8. So this is how you basically concatenate two lists together. So as you can see within my list, what I want to do last is I actually want to remove one value within the list. So what I'm going to do is I'm actually going to remove the value which is 4. So say for an example, what I'm going to say now is actually y, because that's my new list, which is again the list which I got after concatenating list 1 and 2. So what I'm going to say is y.remove. And I'm actually going to remove the value which is 3. So once I run that, I'm actually going to say print y again. And once I do that, so as you can see, my values now are 1, 2, 4, 6, 7, and 8. So because we have removed 3 from the list. Perfect. So these are kind of like the basics for lists, because we now cover different types of examples that you can do within lists. So say for example, if you're using lists, how do you append it, extend it, or actually concatenate it with second list, or actually remove some values from the list. And we have also covered how do you basically slice and dice the list, how you can actually choose certain values from certain index, and how you do actually print those values. But in this now, what I want to do is I want to show different types of iteration that you can do within lists. So with this example, what we are going to use is for loop to actually basically create iteration from one point in the list to the second point in the list. So what I want to do for this is I'm actually going to use for loop. So for looping over my list, what I want to actually use through is for loops. So what I want to use is I want to iterate through my list and basically print out all the values that are in the list. So for this example, I'm going to use for loop. I'm going to say for item in my list, which is my list name is y, and I'm going to say colon and then enter. That actually you can see it basically creates the indentation itself. So once it creates that, I'm just going to say print, and I'm going to say something like item. Once I do that and I say control enter, and as you can see on the bottom, it's basically iterating through all my list values, and it says 1, 2, 4, 6, 7, 8, which is my list values, which is there for list y. Next data structure we are going to look at is dictionaries. Again, dictionaries are also known as associative arrays or hash maps. Again, you're basically mapping keys to the values. The keys can be any hashable type keys, and the values could be anything as you want. And they're basically noted as dict, which is D-I-C-T in Python. So now we're going to look at one of the examples for creating a dictionary. So for this, I'm just going to create a dictionary called names. And within this, I'm just going to say is equal to curly braces open and close, which basically creates a blank dictionary. So once I click enter, that's just a dictionary is now created called names. So within this, what I'm going to do now is I'm going to start adding my key and value pairs in it. So what I'm going to do now is names and then the square brackets, which is for my key. I'm actually going to say something like name1, which is equal to the value, which is again my string value. So I'm just going to pass on the string variable type. And similarly, I'm actually going to add another one as well, which is names. And I'm going to say for that is name2. And the value would be something like Chloe. So once I say print names, and once I click enter on this, as you can see, it's a dictionary because you can see it's been noted into curly brackets open and close, and then you have your key, which is your name 1 and name 2, and your values are again the actual names, which is a string type in this. What if I actually want to look up through my dictionary? So if I want to actually pass on the value and I want to assign that into a new variable, so what I'm going to do now is I'm going to just say something like, in this example, I'm actually going to say name is equal to, and I'm going to pass on my dictionary names, and within this, as you can see, square brackets, I'm actually passing my key, which is I'm going to say name 1, which is one of the keys in my dictionary, and I'm basically passing that key into my another, which is the variable, which is name. So once I pass on this dictionary key within my variable, which is name, and as you can see, it doesn't really pass on the actual key, it actually passes on the value of that key, which is there within my dictionary, and it passes that into the new variable that I just created now, which is name. So if I say something like print that name variable, and once I say enter, and as you can see, it passes on the value which is there in my dictionary for name 1, which is equal to Garv. Similarly, if I actually want to print all the values in my dictionary or all the keys in my dictionary, I can actually use the functions. So I can actually just say print, and within this I'm actually going to say names dot keys and the curly brackets. It basically gives me all the keys that are there in my dictionary, which is name 1 and name 2. Similarly, if I want to look at all the values that are there in my dictionary, I can do something like print names dot values and basically the curly brackets, and once I enter on that, it basically prints out all the actual value that are there in my dictionary. Now, if you've covered two main data structures in Python, which is again your dictionaries and lists, now I actually want to cover like more advanced topics like what's the control flow within Python. Again, Python has usual control flow mechanism where again it's similar to other programming languages as well, whereas also one other difference for Python would be that it uses indentation for a scope. So again, as you can see, whenever we put some sort of statements in this, or if say if else, and once we say colon and we say enter, it actually creates an indentation, as we saw before when we were writing the for loop. So that's how it basically creates a scope within that code. So what I want to kind of like cover now is, as we have covered different types of data structures, now I want to look at maybe looking at more different control flow areas where we are trying to use if else statements or looking at for while loop. So we'll create a basic understanding of those as well to actually have a good grip on coding when we're actually looking into building different types of projects within Python, so we actually understand how do we use these different types of loops or these if else statements. So what I'm going to actually do is I'm going to create two variables first, which is x is equal to 10, and similarly I'm actually going to say y is equal to 15. So what I want to do within this example now is I'm actually going to create an example for if statements first. So I'm going to say something like if x is basically less than y, what I want to do is I want to actually create a message, and I want to have that message is equal to x is less than y, else I want to create a message which is equal to x is greater than y. So once I say print message after this, if I say control enter, and as you can see, because my x value is 10 and y is 15, so x is basically less than y, whereas you can see within this example it says x is less than y. This is how you use if else statement within Python. So one more example, what I want to next look at is how to use for loops. So what I'm actually going to do now is I'm going to say for I in range, and where I'm actually going to say the range is 10, colon, press enter, and as you can see, once I say enter, it basically creates the indentation itself, and once I do that, I'm actually going to say something like print I and is equal to blank. So once I do that, if I don't really put end is equal to the gap, and if I say print in that way, it actually prints the value in vertical way rather than horizontal way. But if I actually pass on saying end equal to the space between them, and if I run that, as you can see, it just basically prints them in a horizontal way. And within this, what I'm trying to do is I'm just trying to print the values till 10, again because index starts from 0 in Python. You can see the values are actually starting from 0 to 9 rather than 1 to 10. Next we are going to look at is while loop. So within while loop, what I want to actually do is I'm actually going to say something like while x is less than y, which is in my example it is, because x is 10 and y is 15. So x is less than y. What I want to do, the operation is x, once I click enter, it creates an indentation, and I will just say x plus equal to 1. So x plus equal to is basically the exact same way of saying x plus 1 is equal to x, but rather than making it more longer, what I'm actually saying is x plus equal to 1. And once I run this, and I can actually just say print. So as you can see, once I say print x, the x value is now changed from 10 to 15. So in the case of while loop, where the condition is that if x is less than y, as we already mentioned that x is less than y, what operation happens is x is equal to x plus 1, which again in this condition we have wrote as x plus equal to 1, which basically adds on 1 to the x value till the time x is actually less than y. So in our condition, the loop will run till the time x value is less than y, and in condition once the x value reaches 15, because y is 15 as well, then the loop will actually stop. So now let's look at one more example of if-else statement, where I'm actually going to also use elif, where there's another condition within my if statement. So for this, what I'm actually going to do is I'm going to say if message, which again is the actual variable we created just before. I'm actually going to say message dot starts with. So when the value is actually starting with x is. So if the value actually starts with x is, what I want to say is actually pass, and if it doesn't, so I'm actually going to create another condition in this. I'm actually going to say elif message dot starts with, and if it starts with y is, then I want to actually print pass again. Or else, which is my last statement within my if else statement, I want to say message is equal to none. So once I run this, it basically doesn't really do anything, because as you can see within my example, if I actually do print message value, which is x is less than y, which is again matches the condition, which is the first condition within my if statement, which is message that starts with x is. So the actual action that happens after this is actually passing it out of the function. So same way, if I want to actually do something in this, what I can actually also do is I can actually say something like message is equal to 0. So if I say message is equal to 0, I'm actually changing the value for, and once I run the exact same function again, it should basically say that message is equal to none. So if I run that, and if I go back and run print message again, so as you can see, the value is now changed to message is equal to blank. So next we're going to look at is functions within Python. Again, functions are declared in Python using def, which is def, and types of arguments are not really specified. So within function, you can actually create functions from scratch, or you can actually use different packages or modules as well to actually use them within your own function as well. So one example I'm actually going to show is creating the function from scratch without using any other functions or modules. So within this function, what I'm actually going to say def, which is the actually how you declare a function within Python. So def is basically, I'm actually going to say something like square. So I'm actually creating a function that basically squares the value of an integer. So once I say that, and I'm actually going to specify one of the variables, which is x, colon, once I press enter, as you can see the indentation happens automatically, and I'm actually going to return the value, which is x multiply by 2. And basically what I do now is I'm actually going to run that function. So I'm actually going to use that function now within my print statement. So I'm actually going to say print and my function name, which is square, and I'm actually going to pass on that x variable, which is again I'm actually passing on 3. And once I do that, and I'm going to press enter, it basically prints out 9, which is my function that actually squares that integer value. So next, where I'm actually going to use another package, I'm actually going to use import sys, which is I'm going to use within my function, and I'm actually going to say something like def. I'm actually going to create a function saying something like kill. Within that kill function, I'm actually going to pass in my message and that message, and after that I'm actually going to say something like print instead of returning. I'm actually going to say something like message, and the file is equal to sys, which is my package that I just imported, .stderr, which is my standard error. And then finally, I'm actually going to just run that function. And once I run that function, so now basically I'm going to call that function. I'm actually going to say kill, and then I'm going to say within that is I am dead. And once I actually run this, so within this example, as you can see, this is now noted into a red column because this is a standard error, that because if you're using a package which is called import sys, we're actually importing that package first, and we're using that package within our function where I'm actually going to passing on that message. I'm actually going to say sys.standard error, so it actually shows that value, it passes that value as it is a standard error. So next, within function, what I'm going to actually look at is how to use optional arguments within your function. So what I'm actually going to do within this function now is, so default values can be given for the arguments by actually specifying them when you're creating the function. And if you don't really want to specify all the default arguments, you can actually specify by the keyword args. So what I'm actually going to do is I'm actually going to create a new function, which is def parse text. Within this, I'm actually going to create my arguments. So the first one is text, and then the second one is a sep, which is I'm going to say separator, which is comma, and then I'm actually going to create another one, which is strip is equal to true or false, which is my boolean argument. So what I'm actually going to do now is within this, I'm actually going to say part is equal to text dot split and by separator. So then what I'm actually going to do is I'm actually going to create an if statement, if strip, so which means if strip is true. So in this example, obviously my boolean default value is true, so which will be true for the start with. I'm actually going to say for I, and then similar way I'm actually going to pass on the part in enumerate, which is parts. And as you can see, the indentation happens, and then I'm actually going to say parts, which is I, and I'm actually going to say part dot strip, stripping that, which it means like taking off all the white spaces. So then after that, what I'm actually going to do is within my if statement there, I'm actually going to just say return, and I'm actually going to return the value, which is parts. So once I'm running this function, my function is now created. So what I'm actually going to do is I'm actually going to parse some text. So within this, I'm actually going to say run the function where I do have some text, which is some text. And as you can see, what I'm actually trying to do is I'm trying to give a lot of spaces within my values. Separated. So as you can see, because like initially what I'm trying to do is once my function gets called, the first thing that's going to happen is it will split all the values by the separator, which is a comma in this situation. And then also what I'm actually going to do after this, I'm actually running the if statement where I'm actually looping through all the values, and I'm actually stripping all the spaces as well. So as you can see, once the values are stripped, they're basically converted into a list. Within that list, you can actually see the values are also stripped, which means like taking off all the white spaces from the start and the end of the actual word, and they're also being converted into a list format rather than being as a string format. So within this, again, another example would be, because I do have optional arguments into this, I can actually convert my strings a similar way. Within this example, I'm actually going to copy this and paste it again, and within that I'm also going to pass another argument, which is again usually it is being mentioned as default, but I can actually change those default arguments. So I can say that strip is equal to false, So what I want to do is I basically want them to be split by commas, but I don't want them to be stripped by white spaces on the start and the end. So once I run this, as you can see, the values are now also converted into a list, but the white spaces are still there within my list. That's how you use optional argument within your function. Similarly, another data structures are tuples. So again, I'm actually going to show you one more example of how do you return multiple values. Tuples are actually like lists, but they are immutable, so you can't really change the values once they are being set in the first place. And they're also noted into round brackets rather than square brackets. So what I'm actually going to say, x is equal to round brackets 1, 2, and 3. And once I print it, it just says 1, 2, and 3. Similarly, you can have different types of data as well within your tuple. So let's create one of the examples within the function and use tuples to return those values. So what I'm actually going to do now is I'm actually going to create this new function in which I'm actually going to say, so I'm actually going to create that function which is def as, say for an example, split extension. And within this I'm actually going to pass my file name. So I can just say index is equal to file name dot rfind and then what I want to say is if index is less than 1, then I actually want to return the file name. It's none. And then I'm actually going to say that the name is equal to file name, starting from the index. Extension is equal to file name. And return name and extension. So once I basically create this function, now I'm actually going to call this function. So I want to actually say, for an example, that because I have two values in this, so I'm actually going to say name and extension, which is ext, is equal to split extension, where I do have my file name, obviously, which is again in the string value, which is image dot jpg. So once I run that, what I actually want to print then is print both the values, which is name, and also print my extension value, which is the actual extension that will come out, which is the .jpg in this example. So once I do that, sorry, I missed the round brackets there. Once I put them back, and what I'm actually going to do is I'm actually just going to run this. So as you can see, it basically prints us both the values. So in this example, we use tuples to actually use within our function. So what I've done in this function is, first of all, I've set index, which is my variable, is equal to file name, which is the actual argument that's been given in the function. And then I'm actually doing .rfind, which is again, I'm finding that dot value. And if it is found, if the index is less than 1, because once it's found, it basically splits them into 2, but if the index is less than 1, which means there is no dot being found in the actual argument that I'm passing. So then what I want to do is I want to just return the file name, and then for the actual second variable, I just want to pass it as none. But if the values are there, so if the dot is there and then actually strings are split into 2, basically I'm slicing the index where I'm actually looking at from the start till the index value, and then extension is obviously file name index plus 1, and then till the end of the value, which is again would be the actual extension. So in that case, I actually create those two variables and pass on the values into that, and then I'm returning name and extension, which again, as you can see, once I passed on the argument for a split extension, which is image.jpg, it basically split that into two values, which is again through using tuples. Now we are going to look at how to create your own class. So again, as you have seen these functions and different examples of functions, the class is just basically a combination of different functions coming together, so you have all in one class. Python classes support many powerful object-oriented paradigms. For example, you can use constructors, method, attributes, properties, inheritance, meta classes, dynamic late binding. Python does not have features like public, private, and protected methods. Within this example, what I'm actually going to now do is I'm actually going to create one basic class where we'll actually use and collect different multiple functions within it, and how to use classes in your Python code. So classes are basically noted with the keyword class, and once you say it's highlighted into green, class, and I'm actually going to name it as particle. And I'm going to pass my object in it. And what I'm actually going to create, so first function usually would be, which is your initialization function, which is again usually basic, which you always have to put in your classes. So within this, I'm actually going to say def underscore underscore init underscore underscore. So I'm actually going to pass on the first thing, which is self. Then I'm actually going to pass other arguments within my function, which is name and speed. And for speed, I'm actually going to say equal to 1, which is my default value for speed. And then once I'm passing that, actually going to say self dot name. So self is basically used to basically initialize that this is an initialization of your own class object. So in this case, what I'm trying to say is self dot name, which then is basically equal to name, which is the actual argument within the function. A similar way, self dot speed is equal to speed. And I'm going to create another function, which is def, say for an example, speed up. And I'm only going to have one argument, which is self. Then I'm actually going to say self.speed is plus equal to 1, which is basically adding 1 to my speed. Similar way, I'm actually going to create another function in which I'm actually going to say def speed down. Within that, I'm actually going to say same self, and within that, I'm actually going to say self dot speed and minus equal to, and that would be 1. So once I've created my class, what I'm actually going to do is I'm going to create a variable, which is, say for an example, p is equal to, and I'm actually going to pass on my class particle. So I'm basically in creating a new variable, I'm actually passing my class object into that variable. So I'm saying p is equal to particle, and then within that I'm actually going to pass my object, which is x. So once I do that, basically I've created an object p, which has my class. So within p, what I'm actually going to do now is p dot, I'm actually going to run the functions within that. So I'm going to say speed up. So within speed up, once I run that, that should basically add 1 to x, which is my value. So because again, the default value for my object x for the speed is 1, as we have created within our function. So once I'm going to run this, I'm actually going to create a print as well. So once I do that, I'm actually going to say print p dot name, and I'm actually going to also say p dot speed. So once I do that, as you can see, it says x is 2. So which is again, x is my p dot name, and then the speed is 2 because 1 was a default, and because I ran the function within that, which is p dot speed up, it basically speeds up the value. So I'm actually going to run the next function, which is again, if I do something like p dot speed down, and same way I'm just going to run the function, and I'm going to print it again, which is the same command. I'm going to copy that, and I'm actually going to run it again. So as you can see, the speed has gone down back to 1 because it's basically subtracting that 1 which is in my function. So this is kind of like how you create a class and how do you run the class. So I have created a new class within that class, and I've actually passed on that value to my variable, which is p. So within that p is my class object. Then I'm running that p dot, which is how you actually run the module which is there within your class. So once I'm running that function which is in my class, again, usually def is usually referred to as a function, but when actually function becomes the part of the class, it becomes as a method. So it's the same thing even if you call it as a method or if you call it as a function, it means the same thing, that you are actually running the function within your class. So once I've created the object for p, which is my class object, then I'm actually running p.speedup, which is I'm running the class method, and once I do that, it basically adds on 1 value to my p.speed. In similar way, once I run p.speed down, it basically subtracts 1 value, which we have created created within our class method. So next, one thing I also want to kind of like cover is when you're creating your own class, how do you actually create your own module, or how do you actually create your own package? So one of the benefits of knowing Python would be that it does come with batteries already installed. So for an example, there's a huge community out there who are actually working on different data analytics packages or machine learning packages, which you can actually use within your own Python code by importing those packages in your code. Similar way, I'm actually going to show you one example on how to create your own package and module, because again, these types of packages and modules also makes your code reusable and really easy to access. Say for an example, you don't really have to work with 5,000 lines of code. Similar way, if you're working in R, you might be creating your own scripts and stuff like that. But with Python, what you can actually do is you can create your own package, and you can actually import those package when you're working on a different Python code. So which makes it a lot easier, which makes it more clean code. So in this video, we'll actually show now one of the examples how to create your own package. So what I'm actually going to do is I'm actually going to leave my Jupyter Notebook running here, but on the background, what I'm actually going to do is I'm actually going to open my Atom now. So once I've opened my Atom, as you can see, I'm in a folder called Python Basics. So what I want to do now is I want to actually create my own package in this. I want to create a Python file here, which is going to be my my first module, say for an example. So I'm actually going to save this file, and what I'm actually going to save this name is as my underscore first module .py. So this is .py is referred as a Python extension. So once I have created this file, as you can see, it says my first module.py, and as you can see on the left hand side, this is where this is the folder which is Python Basics, and you can see my module is created now here. And as you can see, there's one untitled Jupyter Notebook as well, which is again the notebook that I'm actually working on the background. So what I want to do in this is I want to create another function, which will be, so I'm going to create the function within this, which is def my square, and I'm going to pass my argument, which is x, and then I'm actually going to say colon, and as you can see, indentation happens because again it has been saved as .py extension in Atom, and I'm actually going to say return x multiplied by 2, which is my square, and it just squares that value and returns that value. So what I'm going to do now is I'm actually going to save this. And once I've saved, and what I'm actually going to do, another one is I'm actually going to create a new file. Now this new file would be completely blank, but once I'm saving it, the extension that I'm going to save it as is underscore init. This is basically to initialize your package. You always have to kind of like put this empty file in your package folder where you're using this, where you're going to be using this package from. So this is the way you actually represent in Python that this is your actually package, not really just one Python file sitting in a folder. This is actually a whole as considered as a package. So you can actually use to import within your Jupyter code or any other code that you're working in within Python. So what I'm going to do is init underscore init underscore .py. So that's my empty file that's been saved within that location, as you can see on the left. So what I'm going to do now is once I have created my function, it's saved as well. So I'm going to go back to my Jupyter Notebook. So I'm going to say import my first module as md, and within that I'm actually going to say something like md dot, which is my, now I'm going to name the function that is in there, which is my square, and I'm going to pass on the value, which is 4. Once I run this, as you can see, it squares my value and it makes it 16. So it is really easier way to actually maybe write a couple of different types of functions that you want to reuse in different areas of your new code. So you can actually create it as a package within your folder. And as I've created those functions, I can call them in my Jupyter Notebook, or I can call them within my other IDs that I'm using. I can just import that as a package into my new Python code. So again, you can use this to actually make your code more cleaner, as you have multiple functions on the background where you have saved them already in the folder that you can reuse into your new Python code by just importing that module, as similar to a lot of different modules that you already have within Python for data analytics, machine learning, or different areas that you're working in. So again, once we have created those modules, again, one of the main difference between module and packages is that module is just your one Python file that you have created. Again, the package is something that we have just showed in this example where we actually put another file, which is underscore init underscore .py file, which is an empty file. That basically explains Python that this is a package itself. So class this folder res, the Python package, which is again one way of saying is a combination of different modules coming together within one package. So one thing what I want to actually show as well is within my Jupyter Notebook, I'm actually going to show you how to actually import, say maybe we actually imported our own module that we just created within our own package by actually putting that empty init file in it. Same way, how can we actually import modules that are already created by the community. So I'm actually going to import a couple of main modules that we use in Python. So I'm actually going to import now one of the module, which is import math, which is one of the modules that you actually use when you're working in this data science field. So I'm actually going to say import math, and within that I'm actually going to do something like print math.py. And once I run this, as you can see, it just gives you the value of pi. So a similar way, you can actually also do something like from math, rather than saying import math, rather than importing the whole module, I'm just only importing some actual functions within that. Or you can say modules within that package, which is import cos and sine. Within that, I'm actually going to say something like print cos of math.py. So same way, just basically prints the value of pi and print the cost value of math.py. So this way actually you can use some other modules. One other module you could also use is something like import numpy, which is with that I'm actually going to, you can actually say import numpy rather than mentioning numpy every time. You can say as np, so you're just creating that reference for that package. So once you do that, you can actually say something like a is equal to np, now because I've created that reference, dot array, and then I'm actually going to pass on that array, which is 1, 2, and 3. And once I actually say something like print a, it basically prints my array value, which is 1, 2, and 3. Again, NumPy and Pandas are really good packages to use, as they are really easy to use and provide you different types of data analysis tools and data structures that you can work with within your Python code. Next thing we are going to look at is how to use Lambda functions. So for this example, what I'm actually going to do is I'm actually going to bring that function that I created when I was trying to explain how to use functions, which was a square function. I'm actually going to bring that up here and just so I'm actually going to compare these two together. How lambdas are really useful, as you can just do them in one-line functions and you can actually use them within your code. Again, once you get really used to it and get really good grips on coding within Python, more of the times you will actually end up using lambda functions than actually creating these functions. So what I'm actually going to do is I'm going to create the same functions with lambda. So what I'm actually going to say is x is equal to, and same way I'm going, the keyword for lambda function is lambda, which is lambda. And as you can see, the color highlights it. So as I'm going to say is a and a module 2. So this is just my function created exact same way that the other function is. So to see that actual working of that function, what I'm actually going to do is I'm actually going to say print, and where I'm actually going to say x is basically, and I'm actually going to pass on the value, which is 4. So once I run that, and as you can see, it just basically squares the values. So lambdas are really good one-line functions and they're really useful, especially when you're working with large data frames and you have multiple functions and you just want to create some really small functions and just get the work done. Lambda functions are really good to use as a nameless functions, and you can use with other multiple functions like map and reduce and all different types of functions. You can actually plug the lambda function into that, and they're really powerful, especially when you're working with large volume of code. You can actually put lambda functions in some of the places where you actually want to just get the work done and use it for the short time period. Next we're going to look at is list comprehension. Again, list comprehension is where you are trying to avoid loops. You can actually use list comprehension in that case, and again they're often really fast in comparison to actually looping through for loops, and they're kind of like a little mini language within Python where you can actually write code between your list comprehension. So look at one of the examples and you will understand what I mean by that. But in that example we'll also look at using filter and reduce as well. So for this example, first we are going to create our list, which is nums is equal to range 10, which is obviously my 10 values, and I'm actually going to do is print and nums, so I can actually see my values. So which is again says as range is basically within brackets 0 to 10. And so what I'm actually going to do first is I'm going to map. So within map I'm actually going to show something like, say for an example, squares is equal to x into x for x in nums. So within this example, what I'm trying to do is I'm trying to multiply x by x, which is my operation, and I'm mapping this operation to a whole list where I want to kind of like apply this to whole 10 number of integers that I have within my list. I want to apply to each of one of them, and I want to multiply by itself. So which is basically doing the square of that integer value. So what I want to do next is I want to actually print those squares. So as you can see, once I run this, it actually puts that list values, which is 0 by 0 is 0, 1 by 1 is 1, and 2 by 2 is 4. So same way, it actually just does the square for the whole 10 values. So same way, what I'm going to look at next is within this, I'm actually going to filter it using my list comprehension. So within this, what I'm actually going to do now is squares over 10, which is equal to, and now I'm actually going to do x for x in squares if x is greater than 10. Then I'm actually going to print squares over 10. So next what I'm trying to do is I'm trying to do something like, which is using the list comprehension to actually filter out some values from my list. What I'm actually doing is x for x, which means again I'm looking for the value x within my, I'm basically looping through my list, which is x for x in squares. So squares is my list. I'm actually looping through the whole list, and I'm saying if x is greater than 10, basically print that value. So within this scenario, any value which is greater than 10, which is again starting from our 16, 25, 36, 49, 64, 81, which is again the values within the list, they will be printed. Similar way, you can actually use filter and you can actually use reduce. So for reduce, what I'm actually going to do is reduce example, where I'm actually going to say sum of squares is equal to sum squares over 10. So within this, what I'm trying to do now is I'm just doing the sum over the whole list, and I'm actually putting that into sum of squares. So once I do that and I actually say print sum of squares, that should actually just print the value, which is 271. If I look back in our code, we have covered different data structures. We have covered what are different types of operations that you can do. And within the list and within dictionaries, we have also looked at different types of operations that we can do within that. How to use if and else statements, what are different control flows, how to use loops. Also looking at how to create functions and classes within our programming in Python. And again, we have also covered list comprehension and also looking at Lambda functions. And we have also looked at how to actually create our own modules and packages, and also how to use the packages that are created by the community. And finally, we have also covered looking at different examples that you can actually do within your list comprehension and Lambda functions. So before just closing up, we're also going to look at one more last example, which is how to do error handling in Python. So we have covered different examples. Now we are going to look at something like error handling. And within error handling, I'm actually going to show you one example. So first of all, I'm actually going to create one dictionary where D is equal to curly braces. As you can see, it's noted as a dictionary. Value A, which is my key, and then the value for that key is 1, and then the key B, which has a value of 2. So I've created two basically key value pairs, which is my dictionary, and I'm actually going to start writing the code for error handling. So say try if Z is equal to D of, which is again my actual dictionary, and I'm actually trying to access the value for the key, which is C. Again, as you can see in my dictionary, there's no value key. This should give an error. What I want to do is don't really want to see that error. I want to actually say something like except. Rather than seeing that error, I actually want to handle that error. So what I want to say is if it's the except key error as E, I want to actually print a certain value, which is print C is not a key. So as you can see, I'm actually handling that value. by saying this, and once I'm going to run this, as you can see within my dictionary, C is not really the value. So it basically, rather than printing a usual error, what it actually prints is this, the actual error handling that I'm trying to print, which is C is not a key. So I'm to print that instead of giving the generic standard error within this. So you can extend this by also saying finally in it, where print error is shown above. Now again, the idea would be that it will try to do some specific operation, and if it couldn't do it, it will give you that exception error, and then finally will always run in any case. And again, this is really useful to know, again, especially if you're trying to create some sort of connections within your database and you want some certain type of error to know that why did this situation was happened, or why did this error was coming up, that your connection might have not worked. So that type of error handling you can also include in your Python projects. So I hope you enjoyed this video, and if you like the content, give it a thumbs up and do subscribe to my channel and click on that notification sign for my future upcoming videos. And I hope you enjoyed this content and you got your fundamentals clear. I'll leave all the links on the description below. Do download that GitHub repository and try to change a couple of things and create your own functions and your own modules. And if you have any questions, leave it on the comment box below. Thanks for watching. I'll see you in the next video. Peace out.